Welcome to the DevReady podcast. Joining me on the DevReady podcast, I have Antonios Memaris. I don't know much about him. For those of you that are listening and those of you that are new here, this is how I do the podcast. So I'll let Antonios introduce himself and giving a bit of background and who he is and how he's on here. Antonios, thanks for joining me.
Thanks for the invite, Anthony, and it's great to be at your podcast today. My name is Antonios Meimaris. My background is originally from Greece, but I'm currently in Melbourne. We're recording this today. And specifically, my background also is from mathematics. So I'm a research mathematician. My first degree was from the University of Athens in Greece. And then I started straight away my PhD journey working with diffusion models. Some people already know them. They're pretty trendy now, that Gen AI and AI models are like the buzz. But back in the day, diffusion models were not that exciting, one would say. Currently I'm the founder and CEO of PaperLab, an AI company startup, which specifically tries to solve problems for researchers mainly, but other professionals as well, which has to do with the efficiencies that are in place currently and the time that researchers are spending in order to solve their problems and actually start doing their own experiments and working on the research that matters.
So in PaperLab, is it more about helping researchers do more research or qualified, or is it more about the papers that come out of the research with peer review?
It's actually both. The way that this works is that usually, right, when we're talking about the researcher and the whole workflow and the pipeline of things that the researcher does, they actually have to study the literature, what is out there in the academic literature, which is a process called literature review. So in this kind of process, the researchers need to evaluate and try to check what is actually out there in order to find something new, right? In order to innovate, find this kind of like new interesting thing to publish, of course, but also experiment on. So this is where we help. Because, for instance, like there are platforms out there and very good databases out there like Google Scholar, right? So it's like Google but for researchers, where you can use keywords, right? So you can be either very broad or very narrow. So if you are very narrow, yeah, you might find like 5 papers to read or 10 papers to read. You can easily do that, but then you are eliminating other sources of knowledge which would also be relevant to what you're doing. And you might be missing out on some gems out there. If you're very broad, then you would get pages upon pages of results. And this is something that it's not very helpful. Like you cannot really expect a researcher to go through thousands of papers. They would maybe read the title and the abstract of the paper, and that's it. Potentially, once again, you would miss out on some gems that are still out there. So this is what PaperLab does. Like we are and through the developments of AI, we're able now to read and do the insight extraction for the researchers and find the specific parts in those documents that are relevant to their own questions.
So it's a very focused research tool to help them with that very time-consuming and probably difficult literature review.
Exactly. Because usually it takes weeks or sometimes even months to just do the literature review, like getting up to speed with what is out there in the academic literature. Because there are millions of papers getting published out there like every year. And currently, based on our latest statistics, it's like a paper getting published for every 10 seconds.
Oh, wow. And then the challenge is the peer review of those papers.
Yes, exactly.
I can imagine. If there's one every 10 seconds, the throughput is unbelievable.
Exactly.
So what challenge is there then that you're solving on the peer review side?
So on the peer review side, once again, it's about how faster someone can actually do the research, first and foremost, because once again, when it comes to the publication, specifically for the research applications of the platform, you actually want to eliminate or minimize, so to speak, the time that the researchers are spending when it comes to actually doing this kind of like literature review process. We want to expedite the time from like starting their project and actually doing the experiments, doing their own innovative work, right? Now, when it comes to the literature review process, once again, it's much easier now to work in that space as well. Because let's say that you want to analyze and do peer review on a new publication, right? It's not published anywhere. Of course, there's a reference list. not many reviewers can actually go through the tens, some case hundreds of references that are appearing in that kind of space. But now through PaperLab, you can actually do that and see, okay, does that actually matter? And actually do better commentary and provide better feedback to the authors.
Okay, so it's just a huge time saving and it's a focused AI tool to help them.
Exactly.
Was this born from the experience that you've had in your academic history, in your career?
Yes. So once again, because I skipped through that when I was introducing myself. So I started at the University of Athens. Then I was in the UK. I had collaborations with Columbia University in New York. So I was traveling around a lot. I was invited for like conferences and events. Like I was speaking at MIT and Caltech and other places in Europe. And then I got an offer from Monash University, and that's how I ended up in Australia, in Melbourne. So yeah, definitely, this is something that I have seen throughout my journey in the academia, but also when I moved into the consulting space as well for other professionals. Once again, there are many documents that people need to analyze. For instance, when we're talking about the consulting profession, you have the documents that the clients provide you, and you actually have to read that, find what is most relevant, what's most important for the use case, the case study. And once again, you are in essence wasting a lot of time in order to find those kinds of gems.
It's a difficult task to consume information when you have a new project. So we're consultants. You don't know anything about us either. So we're a software development business that are consultants. But again, it's trying to have an information dump when you first meet a client, understand what they're trying to do, who they are, what goals they're trying to achieve. And then the end of the call is, all right, send us anything you have. And the job is to try and consume that and piece that all together to get more context. And that can be a very difficult task.
That's exactly right. Yes. Very. And also, maybe I guess now we should also maybe talk about the differences between other platforms out there. Because, for instance, many people know, let's say, ChatGPT or Gemini or Claude, right? These kind of LLM platforms. Yeah, like in most cases, you could go away with uploading a PDF, let's say, and have it analyzed, right? But when it comes to this kind of volume, like thousands or millions of papers, and also complex and complicated documents, specifically with like chemical reactions, formulas, equations, special characters, tables, right? That kind of information, in most cases, based on the experiments that we have run and doing the market research, so to speak, we have seen, for instance, that those kinds of documents get broken down, like formulas break, tables break. There are cases where we have asked, let's say, ChatGPT or Gemini to just repeat, like not even do some kind of like trend analysis or anything complicated, just repeat a table from a paper. And the LLM said, which table? I cannot find the table. There are limitations with what LLMs can do because LLMs, they're just predicting what is the most probable, so to speak, token word.
Yeah, it's a glorified autocomplete is what I've been calling them. It's protecting the next word in a sentence, taking into account the sentence before, not just the word or two before.
Exactly. And like when you're uploading a document into those kinds of platforms out there, you do not really have clarity in terms of what the model understands out of the document that you have uploaded. So this is the problem mainly, like one of the first steps in the problem that we're solving.
So with your background, I'm assuming you've got a custom model running in PaperLab.
Correct. This is specifically what we have built for researchers, but we, as I mentioned before, we have also seen application for other professionals as well, like in the consulting or in the legal space. Specifically, and I could talk a bit more about like the technical pipeline of what is happening. And I think the most important part is actually this very first step, actually converting the source material that you want to provide the AI into text-only format, because AIs out there actually only understand text. And you cannot really, in this kind of like dummy way of providing a PDF to the LLM, even like a local LLM, like they cannot really understand, okay, what is actually an equation? What is a table? So what we're actually doing in this very first part, we are converting the PDF into markdown format. So it's a specific format which is uh, quite easily used and understood by LLMs. It resembles in a way like machine language. And in that format, we can actually say, look, what comes next is actually an equation, and this is the form of the equation. What comes next now is a table, and so on. So this is like one first part of and a key element of PaperLab. Then, and this is currently open as well. Like anyone can actually use that to try it out. What happens next, though, is in a way like a more powerful Google Drive, if you think about it. So you can create your own libraries, your own folders. You can share it over with other collaborators that you have on your team. So specifically, if I know that Anthony, he might be great, like an expert in audio and visual stuff, right? So I know that his folders have papers in that kind of area of knowledge. So if I want to ask now questions, and I know that you are an expert, right? I can easily just pick, let's say that I want to speak with Anthony's folders, or let's say the whole database that I have access to, and then I'll get responses to my questions entirely based on, in essence, your understanding of the field, like based on your expert knowledge. Once again, it's like not me asking a generic LLM, which might be biased on its training sets and so on. And as briefly I mentioned before, everything is running on our own servers. Like we are not really connected to any LLM provider out there, because this is something that we have seen from mainly the researchers who deal with unpublished research. They do not really want their data out there before it gets published.
Yep, it's not publicly available yet until it goes through that process.
Exactly.
Are you running your own? You're not running a large language model. You're running a diffusion model you mentioned earlier, based on your research or what your area of interest, expertise.
Yeah, so the diffusion part, actually now in terms of like the research and what like new products are coming out, like there are applications of diffusion, and like people are calling them now like diffusion LLMs. So it's the application of how you're using diffusion for the LLM component. We also have an LLM component. I mean, we're happy to connect like your preferred LLM of choice. Like we can definitely do that as well if you are happy with, let's say, trying it out, OpenAI or Gemini, whatever. But ideally, we'd like to keep everything on our closed private system so that like nothing leaves our ecosystem. Now, when it comes to the diffusion, yeah, the diffusion part plays a big role in this kind of like first step of the algorithm of the platform in terms of like converting the documents now into this kind of like text-only format. But we also have an LLM component, which is mainly used in the end of this whole platform, which is just to, in a way, merge all of the useful resources and chunks of information which would be used to provide a reply to the user in a user-friendly manner. In a way, like even without the LLM component, PaperLab would work as like a smarter search machine. So we would just say, okay, this is the query, the question from the user. These are the relevant chunks of information that can be used in order to reply to that question.
Okay. So from my understanding, in sort of like, as far as I understand in the technical sense, where you're going to have a lot more experience, and I may get this wrong.
Sure.
At inference time is when the large language model is collating all the information and presenting it back in a usable way.
Mm-hmm.
But I thought the diffusion model is also for presenting information, not for the initial like reading the information.
Great question. So look, diffusion models have many different applications. Diffusion models can be used not only like for text elements or like images. It can, like, they have applications from like civil engineering and like smart materials to biochemical reactions to quantitative finance applications. So it totally depends on what model is behind the diffusion, like the specific diffusion that you're looking at. And once again, it gets like very, very technical when we're talking about diffusions and like in which specific space, what specific training set you have actually used in order to have like a good diffusion. that will actually work and provide great results for like your application. The specific part that we're using currently is for this kind of translation, in a sense. It's this kind of conversion from PDF to Markdown, this kind of like text-only form.
Because I don't think a lot of people know when they use ChatGPT and they upload a document, they think it's processing the document as is, but what they're doing in the background is, I'm assuming, using Python, reading as much content out of it if possible, unless they have to then do OCR, which is then from the images turn that into text. They turn that into chunks so it can be embedded somewhere, and then they can just query on similarity again. It still doesn't understand the document. It doesn't have any context. It just tries to find words that are similar to the words that you've asked.
That's exactly,
which is different to the diffusion model.
That's exactly right. And like there are many different applications and many companies out there, like AWS with Textract, or for instance, as you said, yes, like when you're uploading a document into ChatGPT, do you actually know what is actually happening in the background? Not really. Like there is some kind of conversion that happens. And you can try to, in a way, try to hack the system, like asking questions. Can you repeat what formula X says? Or like, can you repeat what table Y says? And so on. And in most cases, you can get some kind of result out there. But when you're just uploading the raw, like the raw data, like a raw PDF as is, then the parsing that these models currently do is not that great. And specifically in these applications that we are talking about, which are like very critical, where like an equation could be monitoring something like blood flow, like it might be like in a pharmaceutical application. You cannot really make mistakes. So you cannot like even say, oh, it's just a character that's wrong.
Yeah, there's no room for hallucinations.
If that specific symbol is wrong, then whatever you're doing is going to be wrong. Same case for like legal documents and consulting as well. Like if you actually start with a false hypothesis in a way, then whatever you're going to prepare for your client is going to be wrong.
Yeah, and that's a big thing to be worried about, especially then if you're doing a literature review and you're trying to propose a new concept. If you haven't done the review properly and found all the relevant information that may or may not impact,
exactly,
then you're trying to present an idea that's new, that when it goes for that peer review or that publishing step will just get shot down potentially.
Exactly, because for instance, you might think that what you have been doing is new and innovative, but you might have totally missed like this...
An entire field.
Exactly, like another case study where maybe they didn't use the exact same terminology, but like they have actually started working and looking at this specific object, whatever that is, through another lens. And this would have actually helped you to actually make your paper or like your publication better down the track.
Yeah. And for those that are technical and not listening, on the diffusion side, my understanding, and I'll get you to correct, is that a lot of the image models are using diffusion because it sort of excels in generating pictures. But I think one of the Gemini models is also using diffusion for text output. And my understanding of how diffusion works is effectively if you're doing the image, it's an image of static and it does like multiple passes and cleans the image or tries to get the output that it wants pass by pass in a really simple explanation.
Yeah.
Like it makes the image clearer until it gets the result, the output that it's after.
In a way, yes, we can talk about like what classical LLMs, for instance, do with like this kind of token prediction and what the difference with diffusion is. So in the classic scenario, like you're doing token prediction, then you have like a sentence or a paragraph, then you're going to predict what the next token, like let's say the next word would be, right? So once you do that, then you can do that again and again and again and find word by word what the next part should be like. Now, when we're talking about diffusion, it's exactly as you said. It's like we're doing many different passes through, like we're passing through whatever that might be. Like it could be text, it could be image generation. And in the background, once again, it's about actually moving closer to a specific target that we have, a specific objective. Like this is the mathematical framework. And it goes closer to what maybe a human brain does as well. So if we are thinking about how we are writing a report, not even like I'm not going to talk about an academic paper, but let's say that we're talking about a report. we have maybe done some kind of analysis already, so we are now at the process of actually writing the report. More or less, we already know what we're going to have in the introduction, plus also in the conclusion. Like we might not have even started writing the report, but we already know we have some element, some idea, some vague idea of what we're going to do, right, in terms of writing the conclusion already. So this is an analogy in terms of like how diffusion works. So it does like this very first pass because it already knows somehow what to do for the conclusion part and maybe what to do for the introduction. And then it tries to fill in the gaps, which is mainly resonating in this specific case, how maybe a human brain works.
Yeah. So it's got that direction in mind with the outcome 20% in like clear, and then it just tries to refine that 20% until it gets the complete thing effectively.
Yeah, yeah.
And from what I've read online and looked at and listened to online, the diffusion models are much faster than the current sort of the LLM prediction model.
Yeah, once again, it depends on what kind of model, like diffusion model, you're using. When it comes to production applications, of course, there are many other elements, key elements that are in play that would make these kinds of models, of course, as much efficient as possible. Now, if we're talking about like some kind of very, very complex and complicated application where the diffusion model might be quite non-linear, once again, talking a bit like more technical here, then things might be a bit slower, like on the slower end, but it totally depends on the application, the specific application. If we're talking about like text-only applications, that should be faster.
Yeah, that's what I heard online, especially for like I'm pretty sure it was one of the Gemini Flash models. I think was using the diffusion model to generate the text. So I think that was much faster for that reason. When did you study this when was the period you're studying this compared to say when ChatGPT came out and everything blew up?
Sure, great question. So I fell in love with diffusion models back when I was still doing my undergrad in Greece. And maybe that was back in 2013 or so. That was when I fell in love with diffusion models. And then I started actually doing my academic research on that matter straight after that. So I left Greece in 2015. Yeah. And that's when I also started my PhD journey. And I have been working on that like for many, many years. Mainly the parts that were of interest for me was actually how we would be able to solve these kinds of equations, models, diffusion models, in a faster way than what we actually have or had back in the day. Because once again, NVIDIA GPUs do an amazing job. We can run thousands or like millions of simulations and run our models. Yes, that's amazing. That's great. But what if we do not really have those kinds of resources? Could we find faster ways, like maybe some other way in order to try to approximate this kind of objective that we have in mind? So this was like the part of my PhD journey, of my research that fascinated.
Okay, so you're trying to look at being more efficient or better algorithms in the model rather than
exactly
throwing larger clusters to solve the problem. Because from what I've read, in that time, in academia, the general consensus was throwing more resources wouldn't improve the models up to a point. And then once that, I think it was, so 2016, all you need is information or all you need is attention. Once that paper was released from Google when they introduced the transformer concept, that sort of changed the approach. And then they started throwing larger amount of clusters or resources, and they could see that the models were scaling where they thought there was going to be a scaling limit.
Yeah, look, to tell you the truth, at some point there will be a scaling limit. That's once again, as you mentioned before, like at some point, and currently we are at that point, I believe, where we have already scaled up the resources, so we have already seen the scale up of the outputs as well. But as we are progressing, we're going to see this kind of plateau in terms of the outputs that we're going to get out of these models. So indeed, it's all about as time progresses and we move on, we will actually need to see this kind of like further innovation in these kinds of models, because like LLMs are not the end. LLMs, I think, is just the beginning.
Yep. Well, that's what it is. It's everyone keeps like, I've said it as well 100 times probably, but this is the worst they're ever going to be. tomorrow will be the worst they're going to be again. Like they're constantly improving. But I think where you mentioned they're sort of scaling or plateauing is probably in line with what I'm seeing with there's new models being released, but the benchmarks aren't necessarily showing the growth that everyone's expecting. So you may have there's benchmarks for there's the International Math Olympiad, there's software engineering benchmarks, there's coding programs, and they're going from getting 80s to 85s, then to 90s and 92s, 93s. So they're very incremental compared to where they were a year and a half ago.
Yeah, of course. And I mean, look, if we are going to be realistic, I mean, it takes, I guess, maybe a lot less effort for like someone, if we're thinking about humans as well, right? It takes a lot less effort for someone to actually get a passing grade, to actually for someone to be like the excellent student, right? So, I mean, if we think about it in this kind of scenario, yes. But like we have indeed like seen this kind of huge milestones being hit by these kinds of models out there. But as time progresses, once again, we're trying our best in order to create and make these models as best as possible based on the resources that we currently have. But once again, I think developing and working a bit more on the frameworks and the infrastructure behind what this kind of machinery works is going to unlock the next level for AI.
Oh, definitely. So in your over 10 years of time studying and being in this field, has this last 2-3 years really sort of changed the conversation in how you approach clients and customers? Because now AI is at the forefront of everything compared to before.
Yeah, look, once again, some things stayed the same, some others have changed, and I think that's totally natural. So yeah, like people are saying, "Oh, we need AI, we need AI." Well, not really in most cases. Like
Yeah.
in most cases, some organizations still need to actually try to understand what they can, let's say, automate. And once you are starting to automate and building these kind of robust processes, then you can also think about ways to integrate it with AI. Now, in terms of like other conversations that have changed, for instance, now we're talking about agentic AI. So giving or MCP, so giving to these kind of AI models more privileges or like more tools, access to those kinds of things in order to do stuff for us. But once again, we would say that still pretty early days in terms specifically about privacy and security as well, because there are stories out there where, of course, like you are trying to give them privileges and access to some details, and they could do other things based on these kind of black box models that they are.
I think the other concern on the agent side is there's going to be all these sort of new attack vectors that people haven't thought of yet. Because now if an agent is doing things and you've got like the prompt injection where you can tell it to do things differently, it's very hard to try and control those models to not go against their like system prompt, which is a big problem. So there's one person on the internet, I think his name was Pliny the Elder, the account. He as soon as a new model's released, he'll get the system prompt out of the model within the first couple hours. Like he's figured out a way to get it out of all of them. So it's not something that can be completely protected. But then as a broader use, if you start doing, Google's releasing a payment protocol for agents last week. If you start bringing in payments, now you can introduce even more financial risk, not just the data risk.
Yes, exactly.
As well. Like there's a lot of things to consider about this process. And where you mentioned before where businesses don't need AI or agents, it's a lot of businesses still run on Excel and sticky notes. You're not going to bring AI into that process. You have to have a process in place first before you think about how you can get AI to do it. And if it's a repeatable process, you don't want an agent.
Exactly. And not only that, because like the costs are a little like much lower if you can just automate it using like simple means. Like why should you use an agent or even like an LLM to do something that could be automated through like a simpler process? That's an amazing point that you have actually talked about now, Anthony. And indeed, like in most cases, like you actually hear like those kinds of like CEOs out there, this kind of like C-level executives saying that, oh, we actually need AI, we need AI, and so on. But in most of those cases, indeed, like they're still running things manually. And they could have seen much like time saved and efficiencies through just like trying to automate and like doing this very first step in order to actually maybe even talk about integrating with AI
Yeah.
later down the track.
And on that cost-wise, we've recently been scoping out a project for a client and comparing an agent output versus like a traditional algorithm with some web scraping. It was a 50x difference from the traditional model to the agent. It was 6 seconds versus 6 minutes. And then I think it was a third of a cent versus like $1.50 in token costs, plus then infrastructure to run the agent, plus the pipelining and everything else to manage it.
Exactly.
They're great for non-deterministic output if you don't know how to achieve something and you give it a few tools and let it figure it out. But if it's a step-by-step process, that is not an agent's job. That's the wrong tool.
Exactly. I mean, you can definitely like do it also through agents, but then it's like, oh, I don't really want to think so much about the solution. So yeah, let the agent do it. But since you can actually spare the time and the resources to just think about it, like think about and plan out and structure the process to automate it, then like the cost savings are massive.
It's like the equivalent of having Picasso painting the walls in your house.
Exactly.
It's the wrong use case. It can be done, but it's not utilizing the right tool or resource for the right outcome.
Exactly. That's exactly right.
Yeah. So what are you sort of excited for with PaperLab, or where the industry is going with the fast change that's been happening over the past 20, 30 months, and that's looks like it's increasing?
Yeah. Look, specifically for PaperLab, I just like really want and I hope that some like researcher out there is gonna use PaperLab, and this will try to help him and unlock the next level, and like maybe some kind of like innovative treatment, or I don't know. It might like I just have this hope that indeed like I'm trying to build this platform and this solution that will unlock and like totally minimize and optimize the time in order to actually do new innovative stuff coming out of not just academic research, but also indeed from academic research. And if you think about it, this is like world changing in a way. Because this is what I want to give the resources, the ability to the researchers to conduct the research much faster.
Yeah, and then if you can allow them to do their job faster, hopefully those breakthroughs can come in faster, especially if they're collating more literature review time and more resources than they could have before, then they'll either get an idea or be able to pass that faster to hopefully get through. It's a great goal to, hopefully you can be a part of that.
Yeah. Thank you so much.
Well, Antonios, it's been a pleasure having you on the DevReady podcast today. If anyone wants to reach out and find out more, how can they do that?
LinkedIn is actually the best way to find me, Antonios Meimaris. That's how they can find me. Also, they can send me an email at antonios.meimaris@paperlab.ai. So yeah, these are the best ways of communicating with me.
And we'll add all of that to the show notes. So once again, thank you for joining me on the podcast.
Thank you so much, Anthony. It was great talking with you today.
Thank you.